Hello everyone, good evening all. So today our topic is computer and coding. So in this session we'll start to explain that how exactly programs or codes run inside our computer, digital computer, how exactly the program execute and give output to us. So before I start, so first of all, I think all of you know me. So uh, I would like to inform you something about myself. So I am from West Bengal and I am club head of eCode and also technical head of JK Institute. So and apart from that, my technical strength and achievements that I will say that I'm a MAN developer. MAN exactly means full stack development. Okay, so full stack web development, or you can say. And also, I have expertise in DSA data structure and algorithm. Apart from that, also in my third year, sorry for the interference. We are okay. So, am I audible? Hello.
Yes, sir.
Yes, sir.
Okay. Okay. In third year also I have attended for GATE exam in computer science and engineering, and I have secured a all India rank under 3000. I think maybe some of you know. So let's begin with our session, that is computer and coding. So what will be C first? This is a C program. All you can recognize. What is the output of this program? Can anyone say? Hello. This is a simple, very simple program. Can you explain what
250.
is the output of this program?
सर स्क्रीन मिरर नहीं हो रही है.
क्या इस, इसकी शो नहीं हो रहा है?
सर
नो
आउटपुट
सर,
विल बी
हो रहा है सर, हो
50.
रहा है.
So 50. अगर किसी को दिक्कत होता है तो चैट में भी टाइप कर सकता है.
Excuse me. Hello. Sir, the output will be 50.
या the output will be full 50, of course. So wait. Okay. So we'll see how exactly this program will be executed in our in our laptop or computer. So uh, I think it is very easy. A is equal to 20, B is equal to 30, so A plus B is a student C, so output will be 15. So that is the program. Okay. So how exactly it is working? Let's see. First of all, this program is converted in assembly language. This is the assembly code. Okay. I think this is very hard to understand for humans, but still this is the assembly code, or you can say low level language or second generation language. Okay. C is third generation language, that is high level language, and this is first generation language, the second generation language, that is assembly language. Okay. Every line is an instruction. Okay. Suppose add. Okay. The add instruction doing is, this is two register EAX and EDV. These are two register, and what the add instruction doing is adding these two operand and storing the output in EAX. Okay, that is the meaning of this instruction, and every instruction is similar type of instruction or type meanings. Okay, so these instructions do exactly do one operation at a time. Okay, there are micro operations. So still this is not understandable by our laptop or computer. So what we have to do is convert this into binary language, that is 0 and 1. Okay, so if you want to check how to convert this type of language, you can go to this website, and you can write any program in any language like C or C++ or Java, anything. It will directly convert this language, your program, into assembly language, that is low level language. You can see. Okay, so how actually 0 and on will be represented in our laptop or computer? Can you write 0 or on in our memory? How exactly we are doing that? We're doing that by this type of formula. That is, if I in if I insert a high voltage, that is plus 5 volt or something, is that would be different in different computers or different architectures. Okay, so I am assuming that if I am giving plus 5 volt, that will be 1, and if I am giving nothing, that will be 0. Okay, so 0 and 1 will be represented like this, and this is why we call it digital computer. Digital computer, what is the basic definition of digital computer? The computer which takes digital input and give it as a digital output. Okay, this is the input 0 1 0 1 1 0 1 0, something like that, or this is the digital output 0 0 1 0. Okay, this is the basic definition of digital computer. So let's see how exactly the computer doing this inside our laptop. This is the program. So this program is converted into assembly language, then assembly to binary code is by your compiler. Okay, there is a software that is, I think uh, your seniors have already taken a session on this about how to install uh, compiler in your laptop. So that compiler is doing these things. Okay, this is why we need compilers to convert this program understandable by your laptop. Okay, so let's see the basic working functions of the compiler. So this is the high level language. This is a high level language that is called HLL. This is a compiler design. Okay, so this is a high level language. First of all, this language is inserted in this software as a input. This program is inserted as an input, and there is a preprocessor. That preprocessor is what is doing is some there is an instruction that is called include IO stream. What is the meaning of this? This means that insert this IO stream function or something file into this program before this program. This is an insertion. Okay, include this. What is basically doing this file? This file, there is some definitions of C output or C in or everything, that how the program is working or what is the functions, input output functions are there in our program. So is written in this file iostream. This is a header file. We called it as a header file, and it is already already written in C language, and we don't have to rewrite this program. We can just include it and reuse it in our program. This cout is not a keyword. Okay, cout, there is a some 32 keywords in C programming. Okay, and 64 or 70 something keywords in C++ programming. But cout is not a keyword. Cout is a function, or printf is a function. So printf is the definition of printf or scanf is written inside this IO stream. Okay, so this is why we have to insert this IO stream into our program before compile this. So this preprocessor is doing the same thing. Okay, after inserting this, and also the preprocessor, suppose do you know what comments in programming? If I write something like hi, it is executing without any problem, right? So actually what is doing our compiler is, before executing this program, is deleting this hi line. This is called a commenting. Okay, these things is all done by this preprocessor also. Okay, so we get a pure high level language. Okay, after this pure high level language, we insert it in our compiler. This is a preprocessor that is uh, done before the compilation starts. Okay, preprocessing is before the compilation. So what is compiler doing? Compiler is doing converting this code into assembly code. Okay, this is a second generation code, assembly code. Then we send the assembly language to assembler. Okay, what this assembler is doing basically, this assembler is converting the assembly language to machine code. Machine code means binary code, like this. Okay, this process is converted by assembly language, assembler. Assembly code is converted to machine code by the assembler. Okay, and there is a linker loader. This machine code is relocatable. I think you will not understand right now what is relocatable language and what is not relocatable language. You can understand after I will explain that how the program is stored inside our memory, and how we execute one by one instructions from our memory. Okay, so the program can be stored in anywhere in the memory. So that is why it is relocatable. If the program is not able to store in anywhere, it is a fixed location, then it is not relocatable. Okay, so machine code is relocatable. After linker and loader, that is not that will be a executable machine code. That will be also in the form of 0 and 1, but that will be not in relocatable mode. Okay, so compiler, what is the, there is uh, 1 2 3 4 5 6 processing inside this compilation. So how the compiler is converting the program to assembly language? So there is a six process. First of all, it take all the inputs, and there's a lexical analysis. Okay, what this lexical analysis is doing is, uh, wait, this is the lexical analysis. Lexical analysis is recognizing that this is C. C is a variable. Variable means identifier. Okay, this is the analyzation after the lexical analysis phase. Okay, if anyone have any doubt, you can ask. Okay, then syntax analyzer. Syntax analyzer, there's a thing that is called parse tree. It is taking the stream of tokens. This thing. Okay, this is a look. C is equal to a plus b. This line I have written explain that how compiler is analyzing and converting this C is equal to a plus b in this assembly language. So the phase is first it recognize that what is the this is a variable and this is the equal sign. Okay, this is the assignment sign. Okay, it is just analyzing is something like that, and then it is creating a parse tree. This is called parse tree. What this is, IDE, what is this thing? This is called parse grammar. Okay, every language, C++, Java, and Python, and everything has its parse grammar. Okay, syntax analysis grammar, uh, syntax analyzer grammar. This is the this is called a grammar. Okay, so it just checks if s is a variable. Okay, anything could be inserted in s. You don't have to understand very much deeper in right now. Okay, just remember that after this lexical analyzer, the syntax analyzer part is come and it convert the input to a parse tree. Okay, after the parse tree is created, the compiler go for semantic analysis. What is semantic analysis? Semantic analysis means there is no error, or if there is any error, it will be detected. Okay, so it just check the parse tree. This tree, this is the tree of a c is equal to a plus b. Just check that if there is any grammatical error or any syntax error, anything like that, that will be checked in semantic analyzer. Okay, if this is a valid input, that means this is a valid grammar, then it forward the code to intermediate code generator. Okay, intermediate code generator generates the codes like this. It takes a temporary variable t is equal to a plus b. At a single time it execute only two operand. Okay, uh, let me show you what I'm trying to say. Okay, suppose I have something like a is equal to b into c plus d, something like that. Okay, but the intermediate code generator will do like this. It will take uh, temporary variable t is equal to, first it will execute b into c and store in t, then it will execute, it will do this like t1 and then t2 will be t1 plus d. Okay, so at a single time it only execute two operand. This is a operand b and there is operand that is c. Okay, and there is operand t and t1 and d. Okay, this is the working of intermediate code generator. After the generation of intermediate code, it optimizes and it look for the possible optimization it, the program could be done. Okay, there is something called date code. Date code means, let me show you what is date code. If I do something like that, return 0 here. So this part of the program is called date code. Why? It will never be executed because it will return when it comes to this line. Okay, so this thing called date code. So what the compiler will do, it will just remove this thing, delete this thing, and this is the working of. Sorry for the delay, but okay. So after the code optimization, the code is converted to target code. Target code means the assembly code. This is the target code of this c is equal to a plus d. What it is showing that, first of all, the value of a is fetched from the memory and stored in R1. What is R1? R1 is a register. Do you know about register? Anyone? Hello. Am I audible?
Yes, sir.
Anyone know
Yes,
about
sir.
register in CPU? Okay, don't worry. Actually, register is a small memory, very small memory inside the CPU. Okay, it is. Do you know about this? Wait, let me show you. What is this? Anyone? Somebody respond, please.
Processor.
Yeah, this is a processor. This is a Core i9 processor. This is made by Intel organization. Okay, so inside this processor there is a small memory that is called register, and there are lots of register, means 16 to 20 registers, or uh, 64 registers, something like that. Okay, and every register can store 8 bit or 16 bits of memory. Okay, that is very small, and that is very expensive memory, the memories. Okay, so first of all, this value of a is fetched from the memory, main memory means RAM, where the program is running. From there to the register, and then the value of v is fetched from memory to register 2. Okay, then we will perform the add operation. There is an instruction, a specific instruction, or uh, a specific hardware inside the CPU, inside the Core i5 or Core i9 processor. There is a dedicated hardware that add this to R1 and R2 register, and stored the R1 plus R2 value inside this R1. Okay, it is like R1, R1 plus. sorry, plus R2. This instruction is doing this. Okay, calculating the value of R1 plus R2 and restoring this to R1. And this is a single instruction. This is called a single instruction. In a single instruction, there could be a single operation. Okay, this is called the operation. Okay, let's see something. And in compiler, there is something called symbol tree, the symbol table manager. Okay, what the symbol table manager do is it look at this program. There is a function that is called main function and three variables a, b, and c. Okay, so the symbol table make a table for its understanding for okay something like that. This is a okay, and this is the identifier ID. I've shown this is the ID. Okay, this is the ID. Okay, after the lexical analysis phase, it just create the symbol table ID, and this is a type of int integer type. Okay, int, and the size of the integer is 4 byte. I think all of you know that the size of integer is 4 byte or 2 byte. In modern computers, it is commonly 4 byte, and it where it is stored inside the main memory. This is the main memory. Okay, so the symbol table recognize the address of the all the variables and functions, classes, objects, everything. Okay, so there is a wait. So the C is stored here, and B is stored here, A is stored here. Okay, so it recognizes its address and information about the variables. This is the function, and its size is 10 byte. I just assume that its size is 10 byte, but it could be anything. Okay, it depends on your program size. Okay, now uh, can you recognize this thing? Anyone have seen this before?
RAM.
Yes, sir.
Okay, actually this is a RAM, and I think who have assembled and built a computer in his house or for his, I think most of you, some of you, I think that is a gamer. So the gamer will know what this is. The gamer actually assemble computers and for his gaming. So this is a RAM, and it is inserted into your motherboard. Okay, inside the CPU. And do you know what this is and why this is? Actually, this is a room. What is room? Anyone know? Room. Actually, it's a read-only memory. We cannot write inside this memory. On this is a programmed. Once this is programmed, we cannot change the program after that. We cannot rewrite this, and this is stored into our motherboard. It is uh, attached in our motherboard. Okay, this type of things, and I think in every electronics that is microcontroller to Arduino and every smart electronics that is program that uh, has some program has a room. Okay, even your calculator has a room. So what this room is doing, it stores the basic programs for your laptop or computer, that is BIOS. Have you heard BIOS? BIOS.
Yes, sir.
What is this BIOS? Actually, when you start the laptop or computer, or when you install the Windows inside your computer, we have to run the BIOS program. We can install the Windows or operating systems through this BIOS program, and this is stored inside your RAM, and that is why we cannot delete it or rewrite it. If we update this BIOS, then we will unable to install the Windows program, and that is why the computer will be no use, will be of no use. Okay, and you've already seen that this is a processor. There is lots of uh, pins. If a single pin has broken, then the processor is destroyed. Okay, so never try to do something with that. And do you know what is this? Hello, everyone should know what is this.
Sir, hard disk.
Yeah, this is a hard disk. HDD. We call it as HDD. HDD, hard disk drive. Okay, what it has basically is it stores the data in the form of magnetic fields. Okay, this is a disk. There's a metal disk. Okay, there is not only a single metal disk. There is a some layers of metal disk. Okay, so in every disk and at any point there is a data, single bit of data at any single point. Do you know a single bit? On bit means one bit. What do you mean by one bit? One bit means a single binary data that could be anything, zero or one. So how can we store this zero or one inside this metal disk? Anyone can assume how can we store that this is zero, this is one, and this is written that this will be zero or one by this read write header. This is called read write header. Okay, this is a read write header. Okay, so how exactly we are doing this? We are doing this by, suppose there is a single point, a single magnet. Okay, this is a magnet. Okay, if we suppose that if the north direction of this magnet is, this is the north direction and this is the south direction, and we name it as 0. Okay, and there is another magnet. Its south direction is, this is south direction and this is north direction, and we name it as 1. Can we assume that? Of course we can do that. Then at, and in every single point there is lots of single magnets like this. Okay, and in every magnet we can change the magnetism, its uh, magnetic direction, through this read write header. Okay, we can change the direction. We can suppose now it is north is directing upper side and south is directing bottom side, and we change it through this read write header, that now this is south and this is north. So the 0 will be written as 1 now. Do you guys understand how we store the data inside our disk right now?
Yes.
Can anyone respond? Okay, okay. So, and this disk is divided into lots of parts. Let me show you. This is a disk, okay, and this disk is divided into like this, okay, and this circle is called track, track, okay. This single cycle like this is called track, okay. And how many tracks do we have inside this? One, two, three, four. We are just assuming that inside this disk we have four tracks, but it could be any number. Okay, it could be 100 or 1000 or anything. Actually, it is that there are lots of tracks. It is divided into small circles uh, of the disk, and every track is divided into, right, every track is divided into sectors. Okay, so there is one, two, three, four, 5, and 6. There is 6 sectors inside this disk. Okay, uh, let me show you. This is called a sector. Okay, this is a all single sector, and every sector can store a fixed amount of data like 8 bit. Okay, so how many sectors inside this disk? Can anyone give me the number after calculating? It has 4 tracks, and every track has 6 sectors. So how many sectors total inside this disk? Anyone? Just multiply the number. 6, 6, 6 into 4. Each track has six sectors, and this disk has four tracks. So total four and six into four sectors. And we not only can store the data on this single side of this disk. We can store the data in both the surfaces. In this surface, we can store the data, and in the next surface, let me show you how this look like. Okay. So this is the disk, and there is a read write header that is called ARM. Okay, this is the read write header. This is read write header. Read write header, and this is called ARM. Okay, this ARM can move from here to here. Okay, it can be moved like this. This is the its path. So this is the one front surface, and this this is the back surface, and both the surface can store data, and both the surface have exact same amount of tracks each and sectors. So we have three disk. This disk called platters. Okay, this is called platter. A single disk is called platter, and we could have a number of disks, 4, 5, 6, inside your HDD. Okay, it is not a single disk; it's a layer of disk, and every platter has two two surface surfaces, and every surface has some number of tracks, and every track has some number of sectors, and every sectors can store 8 bit or 16 bits of data. It depends on the architecture and on the organization or company. This is a Toshiba disk, I think. WD Black, the hard disk company name, maybe, whatever it is. Now let's see. So this is CPU, this is your CPU, this is RAM, and this is ROM, and this is secondary memory HDD. I have shown you. So how exactly when we start the laptop or computer, how it starts, reboot or something like that? Firstly, the CPU start execution from this ROM. I have already told you that the ROM is the stored the essential programs of the CPU. Okay, and it starts the program that is called POST. What is the meaning of POST? POST means power on self test. Okay, power on self test. Okay, what this program is doing, when you start your laptop, it just checks that everything is okay or not. What do you mean by everything is okay or not? That every single part of the hardware and input output device is connected to the CPU or not. It just checks everything. Okay, it just checks that in keyboard is connected or not, display is connected or not. If something is not connected, then it will show that your laptop is not connected with this device, hard disk, main memory, or something like that. Okay, so this POST, the first program that runs the CPU from the ROM, read only memory. from this chip. Okay, then it start booting program. After this POST program, in a POST program when show that yeah everything is okay, you can go on or do whatever you want. Then the CPU, this is the first thing. Okay, then the CPU go for next program, that is boot program. BOAT, boot, boot program, booting, start booting. Okay, start the boot program. And what this boot program is do, the boot program go to the secondary HDD memory or SSD memory and copy the OS to your RAM. Everyone know that RAM is volatile memory. Yeah, right? Volatile. Do you know what is volatile? What do you mean by volatile memory? Anyone? RAM is volatile memory. So volatile means if you turn off the power, then this memory is unable to remember anything. So it will forget everything whatever is stored inside this RAM if you turn the power off to cut the power. Okay, that is why it cannot store the OS operating system. Okay, operating system that is Windows 11 or Windows 10 permanently inside your RAM, because whenever you turn off the laptop, it just forget the operating system whatever instructions that. So instructions is stored into your secondary memory. Okay, and then uh, I think secondary memory is two type. There is lots of type, that is HDD, hard disk drive. It is slow, quite slow, and it is very fast. Okay, this HDD is speed is 100 to 200 Mbps, Mbps, and this SSD speed is 2 to 2 Gbps. So you can imagine how fast this is. So this is why if you if you build a computer using SSD, the booting time takes very slow, very um, low. Suppose my laptop has SSD. When I had a computer that is of made of HDD. Okay, and that takes 2 minutes to boot. Okay, and currently my this laptop has SSD and it takes only 7 seconds to start the laptop. So you can imagine that the how fast it could be to start some programs or some operating systems if we install SSD inside the memory. Okay, it uh, so for we are that CPU first start the post POST program, then start booting by actually this is also comes under the booting. Okay, post program, starting post program, then it runs the line by line codes, and there is a code that calls that tells the CPU that go to secondary memory. It tells the CPU that go to secondary memory and copy the OS to RAM, and then the CPU execute the program from this RAM. The CPU cannot directly execute programs from secondary memory. It executes the programs from main memory. This is the main memory. RAM is called main memory. Okay. Have you guys understand this thing? Hello.
Yes, sir.
Are you listening? Listen, you have to focus
Yes, yes, sir.
and
Yes, sir.
give your consent. Okay, okay. You have to concentrate on every word, every single word, whatever I am speaking or saying to you. Otherwise, you will not able to understand this thing. Okay, okay. So now, first, the operating system is copied to our RAM. Now comes the part of this program. If we start this program, now this program will be stored in RAM also. When we write this program, it is in it is in secondary memory in SSD or HDD. Okay, and then when we run that program, then it is also copied from secondary memory to RAM. Okay, head to head. So this is the RAM. First, it stored the operating system, then it stored the program, whatever we run, then it stored the program, the second program, and the other space will be free. And when the power is cut off, this everything of this inside this RAM will be vanished because this is a volatile memory. Do you guys know that RAM is made of capacitors? Do you know capacitors
Yes, sir.
in digital circuits? Yeah. Capacitors can store a single capacitor can store a single bit. Okay, just like the magnetism, the direction says us what bit it is. It is zero or one. Okay, and like that, the capacitor, a single capacitor, can tell us that this is a zero or one. If this is a zero, wait, okay, and inside this program, there are lots of things that is variables, functions, instructions. The main function is is stored here first of all. Okay, the main function. Okay, the program is int a is equal to b, a is equal to 20, b is equal to 30. This instructions is stored here. Okay, then there are literals. Okay, literals and static data. What do you know static data means? Global variable. uh, there is no global variable. Okay, all this, all those are local variable. If I do something like this outside this function, int x is equal to 0, then this is a global variable. Okay, the global variable is stored here, the value of the global variable inside this memory, suppose that is, and there is a stack. That stack stores the local variables like a, b, and c. It stores the value of abc. It does not store the name of abc. Okay, it just stores the value. A is equal to uh, I think it was 20. So it just stored here that there is a 20 in this memory location. Okay, something 101 or something like that. And there is a dynamic memory. Okay, so I think you will not understand what is dynamic memory or heap memory right now. Whenever you will study the data structure and everything, there is there is a thing that is called pointer. When we allocate memory by calling malloc. Have you guys heard malloc or calloc function in C program? That function is allocating the memory inside this heap memory. Okay, and there is a free space, and it is allocated by the OS operating system already to a program. So if it needs extra space after it starts running, then it could store any data inside this free space, this particular program. Okay, and every program is given a free extra space to shrink or increase its stack or dynamic data value. Now, let me show you for this system call. When you start a program, okay, this is a program. When you start this program, this is a, this can be execute very easily. Okay, is going to be inside your CPU, mhm, something like this. Okay, but this instruction requires a hardware that input output device IO device. IO device means input output device that is called display. Why it needs display? Needs display to show the output of C. C out means print the output to the display. Okay, so it needs the access of our output device. So our actually the user programs. This is the user program. Okay, the user program is not allowed directly to interact or communicate with the hardware. Okay, it is only allowed to the operating system. Only our operating system can interact with IO devices, but our user program is unable to do that directly. Okay, but what it can do is it request to the operating system that, hey bro, I need to use this hardware, so can you do this for me? Okay, so this is the thing that user program do to operating system. It request for IO device, and it sends all the necessary data. Suppose the data of this the value of the C, it sends to the operating system that this is the value, just show to the display this value, and this operating system then go to the CPU, go to the CPU, then CPU, it also requests to the CPU that मेरे पास ये आया है, ठीक है, then execute or do this thing to the input output device, and to do that it requires DMAC. What is DMAC? DMAC is direct media access controller. Okay, direct media access controller. This direct media access controller, you can also see that this is actually graphics card. You guys know that graphics card. So CPU tells the graphics card that do these things, and every laptop has a dedicated graphics card. Without graphics card, there is no laptop. We also insert extra graphics card, or you can say high speed, good graphics card, high quality graphics card. But every laptop has a graphics card that is there is a basic graphics card of Intel 128 MB or something like that. But we buy high quality graphics card of uh, I don't know the company's name, but 2 GB, 4 GB, something like that, and the price is very high. Okay, and this whole thing is called not this whole thing. The program when the program tells the operating system to use input output device, that is called system call. Okay, this is how exactly things is running behind our eyes. Okay, okay. So what is this thing? Look at this. This is a program. Okay, and we don't know what is this, what to do with this. So it is already predefined inside our CPU that what this program is doing, how to execute this. Suppose this is like this stream of binary data or binary input is called as instruction. This is a single instruction. Okay, so we have a single instruction like this. So we divide this instruction in some parts. It could be anything, depends on the architecture of computer or which company is making this that architecture. Okay, in generally it is what, divided into 5 parts. The first part is divided like this: opcode. What is opcode? The first some bits like uh, 0 1 0, suppose these 3 bits is telling us, wait, three, uh, wait. This first 2 bits is telling us what is the type of instruction. This is a addition or multiplication or subtraction or division or anything like that. So what is the type of this instruction? What to do? Okay. Look at this. Quality. Well, this is the instruction add instruction. You can see this add instruction. What this add instruction is doing? Just adding to the register's value. Okay. So we already predefined this add with a symbol that is 0 and 1 or something like that. Okay, when this instruction is given to the CPU, it reads the first 2 bits and it identify that it is a type of add instruction. Then it reads next 2 bits. Okay, next 0 and 1. Okay, that is called mode bit. the this mode bit is for this operand and this mode bit is for this operand. Okay, and this will be the location of the operand or the address of the operand. This is also will be the location or address of the operand. Okay, so first mode bit, uh, the mode bit tells us that what is where the operand is stored. It is stored inside a register or inside the main memory. Okay, okay, so this is why we need mode bit. Suppose this 01 means this address is of a register. Okay, or 11 means this address is of a main memory. Okay, and then This is 01, this is 01, this is also 01. Suppose 01 means main memory. So address of main memory. Okay. And then this is the first operand. First operand's address. This first 4 bit. Okay. And then the second 4 bit is the address of second operand. So first we detected that this means is summation plus we have to sum add, and next these two bits means this is the main memory. The operand is stored in main memory. Okay, and this is the address of main memory. Okay, this is the value of that a, and this is the stack. Okay, this is the stack. This the address of a is of here. Okay, and the value of a is stored here. Are you guys able to understand? Hello.
Yes, sir.
Okay, don't worry, I will share the PDF with you so you can recall and listen. This is the basic session. Okay, and this session covers lots of things. There is lots of concepts is taken from lots of subjects like operating system, architecture, compiler design, memory management. Okay, and digital logic, everything. So you may feel that it is hard to understand, but don't worry. This is an overview. Just see like this as a uh, what is going on, how this thing is working. You will read everything. Okay, you will study everything like this of this if you want. Okay, now I have already told you that there is a dedicated hardware to add. Okay, the the CPU detected this 01 or this instruction as the add instruction, and this is already predefined. So it will first fetch the data from memory. Okay, first it will fetch the instruction from the memory. This instruction is also is stored here. Okay, this instruction is also stored here. So first this instruction is uh, suppose this is CPU. First this instruction is fetched from by the CPU, then it decodes the instruction and understand its type. Then it fetches the operands a and b. Okay, it fetches those things. Then it sends the value of a and b to the hardware. Do you know what is this? I think you guys have a subject that is called digital logic in your first sem or second sem, and you have already seen adder, full adder, half adder, something like that. Am I right?
Yes, sir.
Yes, sir.
So this is a full adder. Okay, you can understand this. It's logic. It is made of logic gates. When the CPU detected it as a adding mm, instruction, then it fetches the operands, then sends the operands value to this input and gets the output from here. Have you guys understand? Okay. This is the data path. I
Yes,
think this
sir.
is the last. This is the last diagram, and this is uh, difficult one. Okay, uh, it is a structure inside this thing, this thing. Okay, there is a heavy engineering, and there is lots of minds and brains taken to build this thing. This is a very powerful thing. Okay, so this is a simple basic CPU. Okay, and this is data bus. Have you guys read about buses, control system bus? System bus is of three types. That is data bus, control bus, and what's the other type? There is another type that is data control address bus. ADTRAWS. Actually, this buses are nothing but connecting wires. Okay, the connecting wire that can transfer the bit or a single bit at a single time. See how it is transferring a single bit. If we give a bus, this suppose this is a bus. Okay. So suppose if we give 5 volt of input here, so in, when this part of the hardware receive this signal, it thinks that this is a bit on binary one, and when we do not give any input, it thinks that this is a binary zero. Okay, this is how buses are. Okay, and there is not a single wire that connects that is for only a single wire for data bus or single wire for address bus. There are lots of wires, connected wires for for a bus. Okay, so those are registers. Okay, and every single registers has its own purpose or defined purpose. Okay, one register for storing the instruction that is fetched from the main memory. Okay, this is the instruction, and this is the main memory. Okay, RAM. So we fetch the instruction and through this path. Okay, this path, and stored inside this instruction register. Okay, and this is the address register. We store the address of main memory inside this register. Okay, and data register. This is the data D on. The value of A will be stored here inside this register. Value of B will be stored here inside this register. These registers to store the operand A and B, value of A and B. Okay, and there is a PC. Do you know what is PC? PC means program counter. There is a dedicated register inside every CPU that stores the address of next instruction. This is the current instruction. There will be a next instruction I2, and the address of I2 will be stored inside this PC. Okay, so whenever the current instruction will be executed, the CPU will fetch the address of this PC to get the value or instruction of I, and then send it to the instruction register. And there are some things that is multiplexer. Have you guys? Okay, I think the time is very okay. I will take. 10:30. Okay, it will be fine to continue to 10:30. Hello.
Yes, sir.
Okay, just wait till 10:30. Okay.
Okay, sir.
Okay. Okay. Multiplexer. What this multiplexer is do is it takes multiple inputs and it gives only a single output from the inputs. Means if this multiplexer is taking two input, whenever we sending a signal of one of 0, then it will send this A0, the value of this register, through this way. And whenever we send this as 1, then it will send the value of this PC program counter, the address of next generation, through this way. Okay, at a single time, it could send a single input through it. Okay, and there is a ALU, ALU. Have you guys known about आलू? कि आलू एक सब्जी है जो हर सब्जी में मिक्स हो जाता है. This is not that आलू. What is the full form of ALU? Anyone? बीटेक कर रहे हो तुम?
Arithmetic logic unit.
Arithmetic logic unit. Yeah. So this ALU or ALU do the calculations. Okay. All the arithmetic calculations like this one. Uh, A plus B. Okay. So it could generate. So it this ALU, sorry, actually ALU has this type of hardware inside this ALU. Okay, whenever we tell the ALU that this is a adding ADD, means uh, adding instruction, then the ALU takes the input of A and B and sends to the adder. There is adder, subtractor, multiplier, divider. Okay, so depending on the signals we are sending to the ALU and the instructions we are getting from the main memory, we tells the ALU that this is a we send a specific signal for adding, and then it active a single part of that arithmetic logic unit. That is, if this is a adding function, that it will active this adder. Okay, and it will deactivate all the uh, things like subtractor and everything. Okay, this is how this ALU work. So first of all, let me show you. First, we send the instruction what will be faced through this way. Okay, and this signal is generated by control unit. All those signals, is generated by control unit, CU. There's a dedicated hardware uh, that is actually a basic decoder. Okay, so that sends signal 0 or 1 on a 0. If first, if you I want to send this value, so we have to send 1, then it will pass the value of PC. Then we have to uh, do nothing here. We just tell that just take this input and pass through it. And we suppose we have something like this code, of this signal passing through it, and this will directly doing nothing, no compilation, no calculation, and pass the value through it. Value will pass the value, and this multiplexer also will send one, so send the value. Okay, and then this value is gone to this register, address register. Okay, and what is this in and this out? If we turn on this in by getting the signal on, then this we can write this data, okay, inside this data. And if we turn on this out, then we can out this data. So when we try to insert the PC counter value to this register only, okay, this address register only, then we will active this in for this address register, and every other registers in will be 0, so that this mm, value of PC is not copied to any other register. Then we send this address to memory, and there is a also there is a signal that is called read signal and write signal. Okay, we'll uh, send on for read signal and 0 for write signal. Then this memory will send the instructions value or instruction to this through this data bus. Okay, and then we will send 0 here. Okay, if we send 0 in this multiplexer, it will just directly pass this input and it will cut this input. Okay, and then we get the instruction, and then we have to store this instruction to this instruction register. So we have to do is we have to uh, give 0 signal to this input and 0 on signal to this input, so that this instruction can be copied to this register. So how this things basically work? Okay, okay. This was the session, guys. We have covered a lot of things. I know that it is very hard to understand everything, but still, uh, you get if you get 30% or 40% of the concepts, that will be huge. Okay, am I audible, guys?
Yes, sir.
Hello, anyone response, please?
Yes, sir.
Okay, actually, I have taken some. Actually, I have arranged some questions for quiz, but there is no time, so I will send the questions to the group. You guys will respond to according to, okay, that question on the group. Okay, so this was the session. Thank you guys for being here, and
Thank you,
so
sir.
okay, bye and good night.
Good night, sir.
Okay.
Thank you, sir.